everyone, and welcome to this session on Agentic AI, the future of autonomy. I'm really excited to have you here because today we are diving into one of the most fascinating developments in the AI space right now, which is Agentic AI. As AI continues to evolve, we are seeing a major shift from tools that simply respond to our inputs to intelligent agents that can act on our behalf, take initiative, and even pursue goals. So this session is all about helping you understand what Agentic AI is, how it's different from Generative AI, where it's heading, and how real-world tools like Alexa Plus are already showing us what's possible. So here's what we have got lined up for today. First, we will break down the basics and answer the question, what is Agentic AI? Next, we will take a real-world example such as Alexa Plus powered by Generative AI and see how this showcases agentic behavior. After that, we will explore a key comparison, Agentic AI versus Generative AI, how they are related and how they are different. And finally, we will look ahead at what's coming with an Agentic AI roadmap, the trends, innovations, and what it means for the future of autonomy in AI. So stick around until the end of this session because we will also be building a mini project on Agentic AI together. It's a hands-on way to see everything we discuss in action. But before we get started, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out the Edureka's Agentic AI training course where you will master AI agents. This course is designed by industry experts to equip you for in-demand roles like Generative AI Engineer, LLM Engineer and AI Agent Engineer. This training focuses on strengthening your expertise in Agentic AI development and AI architect design. You will explore essential topics such as conversation patterns and methods to optimize performance and efficiency in no-code AI platforms. In this course, you will work with powerful tools such as Python, Google Colab, LangChain, LangFlow, AutoGen, LangWatch, and many more. So to learn more, check out the course link in the description box below. Now, let's get started. So let's start with the foundation. What exactly is Agentic AI and why is everyone suddenly talking about it? Let's break it down. Agentic AI is transforming industries by allowing machines to learn, adapt, and evolve independently, similar to live organisms. Unlike traditional AI, these intelligent agents investigate, optimize, and develop solutions over time without requiring direct human participation. Recent advancements include OpenAI's deep research, which automatically analyzes massive amounts of data to provide detailed reports, and Google's Gemini 2.0, which improves AI's capacity to plan and reason across different data types. ServiceNow's AI agent orchestrator is transforming enterprise automation by coordinating many AI agents to address difficult business concerns. As these systems become more powerful, they have the potential to unlock ideas beyond the human imagination, ranging from wind turbine blade design to AI-driven company management. So let's break down what Agentic AI is and why it's becoming a game changer in the world of artificial intelligence. So let's start with our first topic, what is Agentic AI? Agentic AI denotes artificial intelligence systems capable of autonomously executing actions to attain designated objectives. Unlike reactive AI, which only responds to the inputs, Agentic AI is proactive, capable of planning, adapting, and making decisions autonomously. So let's explore deep into Agentic AI and see its capabilities. Agentic AI is a type of artificial intelligence that exhibits autonomous behavior, enabling it to take actions and operate without continuous human guidance. It is goal-driven, actively working towards achieving specific objectives rather than passively responding to inputs like reactive AI. And with advanced decision-making capabilities, it can evaluate multiple options, select the optimal course of action based on current conditions and acquired knowledge, and adapt its strategies dynamically in response to unforeseen changes in its environment. Moreover, Agentic AI demonstrates proactiveness by taking the initiative to act rather than waiting for external triggers, making it highly effective in dynamic and complex scenarios. Now, let us see its relevance in the current AI market. When AI systems can act autonomously to accomplish predefined objectives, we call that Agentic AI, making it highly relevant in the current AI market. Its autonomy allows it to operate without continuous human guidance, making decisions and adapting dynamically to achieve objectives. This capability is complemented by its advanced problem-solving skills, enabling it to evaluate complex situations, strategize, and respond effectively to challenges. However, the growing adoption of agentic AI also raises important ethical considerations, such as ensuring responsible behavior, minimizing unintended consequences, and maintaining transparency in its decision-making processes. Now that you know about agentic AI, so let us discuss how it differs from other AI systems. Agentic AI differs significantly from other AI systems in its autonomy, decision-making, and adaptability to achieve long-term goals. Unlike reactive AI, which performs predefined tasks only when prompted, such as spam filters or image classifiers, agentic AI takes the initiative and operates independently. It also contrasts with the generative AI, which focuses on creating content like ChatGPT generating text, but it is not goal-driven. By combining autonomous behavior, strategic decision-making, and the ability to adapt dynamically, agentic AI stands out as a powerful system designed to achieve specific objectives in evolving environments. Now, since we know a bit of differences, let us see the comparison between generative AI and agentic AI. Generative AI and agentic AI differ in several key aspects that define their functionality and applications. Generative AI is primarily focused on creation, excelling in output-focused tasks such as generating text, images, or other form of content. Its adaptability is limited as it relies heavily on prompts for guidance and lacks the ability to operate independently. In contrast, agentic AI emphasizes autonomy, making it goal-driven and capable of dynamically adapting to changing environments. Unlike the prompt-dependent nature of generative AI, agentic AI is self-directed, enabling it to take the initiative and execute strategic tasks effectively. These differences highlight the complementary roles of both AI types in addressing distinct challenges. Now, let us see the impact of agentic AI on various industries. Agentic AI has had a profound impact across various industries, transforming operations and solving long-standing challenges. Autonomous logistics systems such as those in Amazon warehouses have significantly improved operational efficiency by 30 to 40%. In healthcare, AI-enabled surgical robots like the 𝐑𝐴 system have performed over 10 million less invasive procedures worldwide, enhancing precision and patient outcomes. Scientific advancements have also been transformed by systems like DeepMind's AlphaFold, which successfully solved the decades-old protein folding problem. On a global scale, the World Economic Forum predicts that by 2025, AI will displace 85 million jobs while creating 97 million new ones, reshaping the labor market. And in the energy sector, AI-powered smart grids can reduce electricity waste by up to 10%, promoting greener energy solutions. Additionally, over 90 countries are investing in AI-enabled military technology to modernize their defense systems, showcasing the strategic importance of agentic AI in global security. Now, let us see the applications of agentic AI. Agentic AI is transforming various industries by enabling systems to make autonomous decisions, adapt to changing environments, and achieve specific goals. Autonomous vehicle powers self-driving cars and drones to navigate roads, avoid obstacles, and make real-time decisions, as seen with Tesla Autopilot and autonomous delivery drones. In robotics, agentic AI allows industries, healthcare, and exploration robots to perform complex tasks independently, as demonstrated by Boston Dynamics robots used in logistics and rescue operations. Personalized virtual assistants like Google Assistant and Amazon Alexa leverage agentic AI to predict user needs, manage schedules, and execute tasks without direct commands. And in gaming, adaptive AI agents enhance the experience by creating challenging, human-like opponents, such as AlphaGo and AI bots in the real-time strategy games. In healthcare, agentic AI supports personalized treatments, accurate diagnostics, and surgical assistance with examples including AI-driven surgical robots and systems for remote patient monitoring. These applications demonstrate the transformative potential of agentic AI across diverse domains. Agentic AI is making a significant impact across various industries by enabling autonomy, adaptability, and efficiency in diverse applications. In finance, it powers algorithmic trading systems and fraud detection tools, optimizing financial operations such as managing investment portfolios and identifying fraudulent activities. In smart cities, AI systems manage energy consumptions, optimize traffic flow, and enhance public safety with examples like smart traffic lights adapting in real time and autonomous energy grid optimization. In space exploration, autonomous spacecraft and planetary rovers such as NASA's Mars rovers perform exploration tasks independently. In education, AI-powered tutors like Carnegie Learning provide personalized instruction by adapting to individual learning styles. In military and defense, autonomous drones and surveillance systems improve situational awareness and decision-making, such as AI-driven surveillance drones in defense applications. Now, let us see the challenges and risks associated with Agentic AI. While Agentic AI offers tremendous potential, it also faces several challenges and risks that must be addressed to ensure its safety and ethical deployment. So one key concern is misalignment with human goals, where AI systems may pursue objectives that conflict with human intentions due to poorly defined parameters or unintended consequences, such as autonomous robot prioritizing efficiency over safety. Ethical questions arise regarding accountability and decision-making, demonstrated by the challenge of determining who is responsible when an autonomous vehicle causes an accident. The complexity of decision-making in Agentic AI can also lead to a lack of transparency, making it difficult to understand or explain its actions, particularly in sensitive fields like healthcare or finance. Ensuring safety and reliability is another challenge, as AI systems must operate effectively in unpredictable environments, such as autonomous drones encountering extreme weather or medical failures. Additionally, Agentic AI systems often require substantial computational resources, making their deployment costly as seen in advanced robotics and self-driving cars. Security vulnerabilities pose further risk, as autonomous systems could be targeted by cyber attacks, potentially leading to harmful consequences like the manipulation of autonomous vehicles. Lastly, overdependence on AI may reduce human oversight or lead to skill degradation in critical areas, such as relying too heavily on autonomous systems for medical diagnosis without human validation. These challenges highlight the need for robust design, rigorous testing, and ethical frameworks to mitigate risk and maximize the benefits of Agentic AI. Now, let's see the future of Agentic AI. The future of Agentic AI is said to be transformative, with advancements across various domains influencing its deployment. Future systems will exhibit increased autonomy and adaptability, enabling them to make complex decisions in real time and operate effectively in dynamic environments without human intervention. The integration of Agentic AI with advanced technologies like quantum computing, IoT, the edge computing will further enhance its capabilities, allowing for faster decision-making and real-time processing at the edge. These systems will have the widespread applications in sectors such as healthcare, where they will enable autonomous medical diagnostics, personalized treatment plans, and robotic surgery. Climate action with advanced systems for environmental monitoring and response, and space exploration, where smart rovers and spacecraft will carry out missions on their own. As these technologies evolve, ethical concerns and accountability will need to be addressed, promoting the development of regulatory frameworks to ensure responsive AI usage. Additionally, Agentic AI will foster human-AI collaboration, enhancing productivity and creativity in the fields such as education, engineering, and research. Now, let's take a quiz question. And the question is, in Agentic AI, an agent is best described as, and the options are A, a chatbot interface, B, a human supervisor, C, an autonomous system that can make decisions, or D, a plugin for large language models. And if you know the answer, please drop it in the comment section below. Now that we know what Agentic AI is, let's bring it to life with real-world example. You might have heard about the latest update to Alexa, Alexa Plus. It's not just powered by generative AI, but also integrates Agentic AI models that allow it to take initiative, understand goals, and act autonomously. So let's see how this fits into the bigger Agentic AI picture. Amazon just dropped a major AI upgrade, Alexa Plus, and it's unlike anything we have seen before. It's not just an update, it's a complete transformation powered by generative AI. But what exactly makes Alexa Plus smarter, more conversational, and more capable? Well, in this video, we will break down how Amazon has leveraged state-of-the-art AI models to make Alexa a true AI assistant, how it compares to competitors like ChatGPT Voice and Google Assistant, and whether it's the future of voice AI. Let's rewind a bit. Alexa started as a simple voice assistant in 2014. It could set reminders, play music, and control smart devices. But it had one major limitation. It wasn't really thinking, just following predefined rules. As AI advanced, assistants like Apple Siri and Google Assistants improved. But Amazon saw an opportunity to turn Alexa into a true conversational AI. And that's where generative AI comes in. Enter Alexa Plus, a brand new AI-powered version of Alexa that understands context, remembers conversations, and sounds more natural than ever. So in today's exciting video, we are going to talk about the new launch of Alexa, that is Alexa Plus. So let's begin with an introduction and overview of Alexa Plus. Launched on February 26, 2025, Alexa Plus is Amazon's next-generation AI assistant designed to provide more natural, conversational interactions and enhanced capabilities. This upgrade enables Alexa to perform complex tasks such as planning events, managing schedules, and controlling smart home devices more efficiently. Alexa Plus represents a significant evolution from the original Alexa, introducing several key enhancements. So let us see what are they. First, we have conversational abilities. Alexa Plus offers more natural and expansive interactions, understanding colloquial expressions and complex ideas, making conversational feel smoother and more intuitive. Building on that, it also takes a more proactive approach to assisting users. Unlike the original Alexa, which primarily responded to direct commands, Alexa Plus can anticipate user needs such as suggesting earlier dispatches due to traffic or notifying about sales on desired items. In addition, it has become more personalized than ever. Alexa Plus can remember user preferences, dietary restrictions, and important dates, tailoring responses and actions to individual needs, whereas the original Alexa had limited personalization capabilities. Beyond personalization, it also enhances task management. The new Alexa can handle complex tasks like making reservations, ordering groceries, and coordinating multiple services seamlessly, surpassing the more basic functionalities of the original Alexa. Not just that, it also integrated with more services than before. Alexa Plus connects with a broader range of services and devices, including Grubhub, OpenTable, Ticketmaster, and various smart home products, making it even more versatile. On top of all these improvements, it now has the ability to act independently. Agentic capabilities is a notable advancement in Alexa Plus. Now that we have seen how Alexa Plus has improved, so let's dive into the technology behind it and understand how generative AI models and agentic AI capabilities power this next generation assistants. Alexa Plus is built on cutting-edge generative AI and agentic AI, leveraging powerful models and algorithms to process language, understand context, and execute tasks autonomously. So let's break down the key technologies that make this possible. Large language models, which is LLMs, the brain behind conversations. At the core of Alexa Plus is an advanced transformer-based language model, similar to GPT-4, Claude, and Amazon's proprietary Titan model. These LLMs are trained on vast datasets, allowing Alexa to understand complex queries and respond naturally. Also maintain context across conversations, making interactions feel more fluid, and generate human-like responses, reducing robotic and repetitive phrasing. And by using techniques like reinforcement learning with human feedback, Alexa Plus continuously improves its conversations ability based on real-world interactions. The next technology is Agentic AI, enabling proactive and autonomous actions. Beyond just responding to commands, Alexa Plus integrates Agentic AI models which allow it to act independently. Built on RAG and action models, it can plan multi-step tasks, example finding a restaurant, booking a table, and arranging transportation. It retrieves real-time web data to provide the latest information and execute action across multiple apps and services without user micromanagement. This enables a fully autonomous AI assistance experience, reducing the need for manual user input. After Agentic AI, the technology that makes Alexa so versatile is neural network architectures, enabling speech and context awareness. Alexa Plus utilizes deep learning techniques such as sequence-to-sequence models for natural language generation, BERT, which stands for Bidirectional Encoder Representations from Transformers, for understanding user intent with greater accuracy. Next, Whisper ASR, Automatic Speech Recognition, for improved voice processing, making Alexa more responsive to different accent and speech patterns. These advancements enable highly accurate speech recognition, contextually understanding, and real-time adaptation to user behavior. Alexa Plus integrates long-term memory storage using vector databases like FAISS or Amazon Aurora, allowing it to remember user preferences over time, adapt to individual habits and routines for a more personalized experience, also provide contextual reminders based on past interactions. This deep personalization is what makes Alexa Plus feel more like a true digital assistant rather than just a voice-controlled device. Then comes the technology that makes Alexa Plus capable of understanding and interacting with user, which is multimodal AI. Alexa Plus leverages multimodal AI combining natural language processing for text-based queries, computer vision for 𝐂𝐞𝐫𝐵 devices, enabling it to process and analyze on-screen content. Also, the speech synthesis is used to generate human-like voice responses. And this makes Alexa Plus capable of understanding and interacting with user in multiple ways, enhancing its overall functionality. And by combining LLMs, Agentic AI, deep learning models, and real-time data retrieval, Alexa Plus represents a significant leap in AI-driven virtual assistants. It is no longer just a voice assistant, it is an autonomous, context-aware, and highly personalized AI companion designed to make daily life easier. Now that we have explored the technology behind Alexa Plus, so let us see how it stacks up against other leading AI assistants. Alexa Plus enters the AI assistant space with generative AI and agentic AI, making it smarter and more proactive. But how does it compare to the top AI models available today? So let's break it down across key aspects. So we will compare them based on 5 key factors such as AI powered and capabilities, personalization and memory, then proactive and autonomous tasks. Next is the ecosystem and third-party integration, and finally conversational abilities. So first, let us compare it with AI powered and capabilities. So how powerful is the AI behind each assistant? Alexa Plus uses Amazon Titan plus custom LLMs with generative AI and agentic AI for smart, proactive responses. Whereas ChatGPT voice runs on GPT-4, great for deep conversation but lacks real-world task execution. Whereas Google Assistant uses Gemini AI, best for search and multimodal inputs such as text, voice, and images. And Apple Siri uses Ajax LLM, improving in language but still rule-based and limited. So Alexa Plus leads in proactive AI while GPT-4 dominates in conversation. Next, let us compare it in terms of personalization and memory. So can the assistant remember your preferences and adapt? Let us see. So Alexa Plus long-term memory of routines, preferences, and contextual adaptation. ChatGPT voice limited memory, resets after sessions. Whereas Google Assistant remembers preferences inside Google apps but lacks deep personalizations. Apple Siri is minimal memory, mostly relies on Apple's preset commands. So Alexa Plus leads in remembering and adapting to users. Next is the proactive and autonomous task execution. So can it handle tasks on its own? Let's see. Alexa Plus uses agentic AI for multi-step automation, for example, booking, ordering, and reminders. ChatGPT voice assists with planning but can't perform real-world automation. Google Assistant can set reminders and retrieve information but lacks deep automation, whereas Apple Siri, limited to commands, relies on shortcuts for basic automation. So here the Alexa Plus is the most proactive, handling tasks automatically. Next is the ecosystem and third-party integration. How well does it work with other devices and apps? Well, Alexa Plus is best for smart home, such as Amazon Echo, Ring third-party integrations. ChatGPT voice can connect to some external tools but no smart home control. Google Assistant is deep integration with Google apps and services, whereas Apple Siri is limited to Apple devices with minimal third-party support. So here, again, Alexa Plus and Google Assistant lead, but Alexa has better smart home control. And finally, conversational abilities. So how natural and human-like are the conversations? Alexa Plus is natural, expressive, and context-aware. ChatGPT voice is best for deep, intelligent conversations. Google Assistant is accurate but more search-focused. Apple Siri is still command-based with limited depth. So ChatGPT voice is best for deep conversations, but Alexa Plus is most natural for voice interactions. So now let us see the future of AI assistants. Let's see what's next. So here we have smarter AI memory. Assistants will remember and personalize even better. Next, more autonomy. AI will handle complex multi-step tasks independently. And then, more human-like conversations. AI will feel more natural and intuitive. Next, seamless integration. AI will connect effortlessly across devices and services. Next, real-time decision making. AI will anticipate needs and offer proactive help. So Alexa Plus is best for automation, memory, and smart home control. Whereas ChatGPT Voice is best for deep intelligent conversation, Google Assistant is best for search and Google productivity, whereas Apple Siri is best for Apple users but still limited in AI features. And Alexa Plus is not just an upgrade, it's a redefinition of AI assistants with generative AI and agentic AI for smarter proactive help. So what do you think? Which AI assistant is your favorite? Let me know in the comments below. So, how does agentic AI compare to traditional generative AI? Are they the same? Let's see. And this is where it gets interesting. So let's explore the key differences.
Imagine asking ChatGPT for a poem and it writes one instantly. Now think about an AI assistant planning your entire day, booking meetings, and even handling emails without your constant input. That's the difference between generative AI, which creates content, and agentic AI, which acts with autonomy, making decisions. In 2025, as AI becomes more than just a tool, understanding this shift is very critical. Are we heading towards just smarter chatbots or truly independent digital agents? Let's break it down through this video. Let's first break down what generative AI is. Generative AI is a type of artificial intelligence designed to create content, whether it's text, images, music, or even code. Instead of making decisions or even taking action on its own, it focuses on producing outputs based on the patterns it has learned from the vast amounts of data. At its core, generative AI models use deep learning techniques like transformers to generate new content that resembles human-created work. For example, ChatGPT generates human-like text based on prompts, Midjourney and DALL-E create stunning images from simple text description, and GitHub Copilot helps developers suggesting code snippets in real time. Generative AI has several strengths. It enhances creativity and productivity, allowing artists, writers, and programmers to work faster and even more efficient. It scales effortlessly, generating unlimited variation of content in just few seconds. It also adapts responses based on user input, making interactions feel more personalized. But it also comes with few limitations. Generative AI lacks autonomy. It doesn't think or act on its own. It only responds when prompted. It has no real decision-making abilities and cannot evaluate consequences or make even independent choices. Additionally, it can generate biased or inaccurate content based on the data that it has seen. While generative AI is powerful for creating, it cannot act independently. And that's where agentic AI comes in. Let's explore what agentic AI is. Agentic AI goes beyond just generating content. It acts autonomously, making decisions and executing tasks without the need of constant human input. Unlike generative AI, which can only respond to prompts, agentic AI can plan, adapt, and take initiatives based on goals rather than the specific instructions. At its core, agentic AI combines reasoning, memory, and decision-making to operate more like an independent agent. It doesn't just create, it analyzes, strategizes, and acts. Real-world examples include autonomous robots, which navigates and complete the task on their own. AI-driven personal assistant, like those managing schedules, booking flights, and handling emails without human oversight. Even self-driving cars, which continuously assess their environment and make split-second driving decisions. Agentic AI has its own strengths. It reduces the needs for manual intervention, automating the complex workflows. It adapts to real-world conditions, learning and improving over time. It can even handle multi-step tasks that require planning, execution, and adjustment. But it also has its own challenges. Developing truly autonomous AI requires significant advancements in reasoning and adaptability. There are certain risks, including unintended behaviors and ethical concerns around AI, which makes independent decisions. And unlike generative AI, which focuses on creativity, agentic AI is limited in how well it can generate novel content. So while generative AI creates and agentic AI acts, the real powers comes when these two work together. Let's see the key differences between generative AI and agentic AI. Generative AI and agentic AI serve different purposes, each with unique strengths and applications. The key distinction comes down to creativity versus decision making. As previously discussed, generative AI focuses on producing content, whether it's text, image, or code. It enhances creativity by assisting writers, designers, and developers. But it lacks true autonomy. It only works when prompted and doesn't make any decision on its own. Agentic AI, on the other hand, is designed for interactions and execution. Instead of just generating responses, it can analyze situations, make decisions, and take actions. While it may not create content like generative AI, it can manage workflows, automate tasks, and adapt to real-world conditions. Another key difference is user dependency. Generative AI is entirely reactive, meaning it requires human input to function. It waits for prompts before generating anything. In contrast, Agentic AI is proactive. It can initiate actions independently, setting reminders, optimizing schedules, or even solving problems without human intervention. The applications of these AI types also differ. Generative AI is widely used in content creating, marketing, entertaining, and software development. And Agentic AI powers autonomous systems like self-driving cars, AI-powered customer service, and personal assistant that can handle complex workflows. Both AI types are transforming the industries. But when they work together, they unlock even greater potential. Imagine an AI that not only generates a marketing campaign, but also launches it, tracks engagement, and refines the strategy automatically. The future isn't just about choosing between generative AI and agentic AI. It's about combining them two to build truly intelligent systems. Now that we understand the key differences between these two, let's explore the future of AI by asking, will generative AI be replaced? As AI continues to evolve, one big question arises. Will agentic AI replace generative AI? Right now, generative AI is everywhere, helping people write, design, and code faster than ever before. But it has one major limitation. It relies entirely on human input. Agentic AI, on the other hand, takes things further. It doesn't just generate, it decides, plans, and even acts. It's the next step towards the true autonomous intelligence. Does that mean generative AI will be obsolete? Not necessarily. The future of AI isn't about one replacing the other. It's about coexisting. Generative AI will keep getting more creative and even sophisticated, producing even higher quality content. Agentic AI will become even more autonomous, integrating deeper with industries like healthcare, finance, and robotics. But this shift does come with some risk. As AI takes on decision-making power, we face new challenges, ethical concerns, unintended consequences, and the need for accountability. If an AI agent makes a bad decision, who is responsible? And how do we ensure it aligns with the human values? The answer lies in balance. The real future of AI is hybrid approach, where generative AI fuels creativity and agentic AI drives intelligent action. Imagine an AI system that not only writes a research paper, but also submits it to journals, responds to reviews, and refines it automatically. And this is where we are headed. Not just smarter AI, but AI that truly works with us as both a creator and an agent. The question isn't whether agentic AI will replace generative AI. It's how we'll harness both to shape the future of intelligence. Now that we have explored the differences between generative AI and agentic AI, let's move on to building an intelligent AI agent that can interact with our database using natural language. This means you can simply ask a question like, show me all the students who have scored above 80, and the agent will automatically convert it into an SQL query, fetch the data, and return the exact result from the database. No need to write complex SQL queries manually. Just ask and the AI responds. Let's dive in and build this powerful system. First, we need to set up a Conda environment to manage our project dependency. To do this, we open the terminal and run the following command. We'll write conda create -p vnv Python equals to 3.10-y. So, Conda creates a new Conda environment and -pvnv specify the environment path as vnv. Python equals to 3.10 installs Python version 3.10 inside the environment, and -y automatically confirms the installation without asking for approval. Once the process is complete, our virtual environment is ready, and we can move forward with setting up our Agentic AI project. Next, we'll create a file named requirements.txt. where we'll list all the necessary libraries for our project. This will help us easily install dependencies in one go. Additionally, we'll create a .env file to securely store our Google Generative AI API key, keeping sensitive information separate from our main code. With these files in place, we ensure a well-structured and organized setup for our Agentic AI project. First, we will work with SQLite, a lightweight self-contained database engine to create and manage a student database. Let's break it down step by step. So we'll create a file named sql.py and import the SQLite 3 module, which allows us to work with SQLite databases. We'll write import SQLite 3. This module provides all the necessary functions to create a database, insert records, retrieve data, and manage connections. Next, we create a connection to an SQLite database file named student.db. We'll write connection equals to SQLite3.connect, connection equals to SQLite3.connect, in the bracket, in double inverted comma, student.db. If this file doesn't exist, SQLite will automatically create it. The connection object will allow us to interact with the database. Now, we create a cursor object, which is used to execute SQL commands in Python. We'll write cursor equals to connection.cursor. Think of the cursor as a tool that helps us send queries to the database and retrieve results. Now, we define a SQL command to create a table named student with 4 columns. We'll write table_info equals to triple inverted commas. Next, we'll create a table. For that, we'll write create table, then student. We'll write in the bracket name type varchar, and we'll have 25 characters, comma class type varchar, and the same 25 characters, comma section type varchar with 25 characters, and marks type integer. Then we'll write cursor.execute in the bracket table_info. The name stores the student's name string up to 25 characters. The class stores the class's name. And the section stores the section of the student. And lastly, the mark stores the marks obtained as integer. Executing this command creates the table in the database. Next, we insert 5 student records into the student table using SQL insert statements. I've already created and inserted 5 values in the table. You can create as much as you can. Each insert command adds a new role with the student's name, class, section, and marks. Now we retrieve and display all records from the student table. For that, we'll have to write print in the bracket the inserted records are. In the next line, we'll write data equals to cursor.executed in the bracket 3 single inverted comma select star from student, closing the inverted commas in the bracket. Then we'll write for row in data colon print in the bracket row. The select star from student query fetches all the data from the table. The for loop iterates through the records and prints them one by one. And finally, we commit our changes and close the database connection. For that, we'll write connection.commit and then connection.close. The .commit function ensures all the changes are saved in the database. The .close closes the connection, freeing up the system resources. And that's it. We have successfully created a student database, inserted records, and retrieved them using SQLite and Python. Now, let's build an interactive Streamlit app that converts natural language questions into SQL queries using Google's Gemini model. It then retrieves data from an SQLite database and displays the result. Let's break it down step by step. But before we start, we have to activate the environment. For that, we'll write activate venv /. And here our environment is activated. First, we'll create a file named app.py and load environment variables using .env. For that, we'll write from .env, we'll import load_.env. Next, we'll write load_.env. It will load all environment variables. This ensures that sensitive information such as API keys is securely stored and accessed. Next, we import the necessary modules. For that, we'll write import Streamlit as st, then import OS, then import �SQLite3, and then import google.generative AI as GenAI. Streamlit here powers the web interface. OS helps access the environment variables. SQLite3 allows us to interact with the database, and Google Generative AI enables the conversion of natural language into SQL queries. Now, we configure the Google Gemini API key. But before that, we'll have to create an API key through Google Studio itself. I've already generated one. You can create yours through Google Studio itself. Then we'll write genai.configure in the bracket API_key equals to os.getEnv, and in another bracket Google_API_key. This allows the app to use Gemini 1.5 Pro to generate SQL queries. Then we define a function to generate SQL queries from natural language input using Gemini. For that we'll write def get_Gemini_response in the bracket question, prompt. Next, we'll write model equals to GenAI, generative model. In the bracket, we'll write models / Gemini version 1.5 Pro. Then we'll write response equals to model.generate_content in the bracket, and in square brackets prompt in the square bracket 0 and question. And then we'll write return response.text. The function initializes the Gemini model. It takes a question and predefined prompt as input, and the AI model generates an SQL query as output. Next, we define a function to execute SQL queries on the database and retrieve results. For that, we'll write def read_SQL_query in the bracket SQL, DB. Next, we'll write con equals to SQLite3.connect in the bracket DB. Then CUR equals to con.cursor, and then CUR equals to execute in the bracket SQL. Then we'll write rows equals to CUR.fetchCall, then con.commit, and then con.close. And then we'll create a loop by writing for row in rows, and then we'll print it, and then return rows. The function connects to the student.db database. It executes the given SQL query, and it fetches all the retrieved records and prints them. Now, we define the AI prompt that instructs Gemini on how to convert the questions into SQL queries. As you can see, I've already created a prompt for my own, and you can create yours according to how you want your model to function. If you want the prompt which I've used over here, you can just comment on the video and I'll send it to you. This prompt ensures the Gemini AI generates SQL queries accurately without unnecessary text. Now, we'll set page configuration with a title and icon. For that, we'll write st.set_page_configuration in the bracket page_title equals to SQL query generator, Edureka, page_icon. Then we'll display the Edureka logo and header. For that, we'll write st.image in the bracket 123.png, width equals to, let's keep it as 200. st.markdown in the bracket logo plus Edureka's Gemini app / your AI powered SQL assistant. Next, we'll write st.markdown, then the logo, and ask any questions, and I'll generate the SQL query for you. The page title and the icon are set. A logo is displayed at the top, and the app's purpose is to introduce to the user. And before we import the logo, just make sure that you have the logo in your folder. We take user input for a natural language query. For that, we'll write question equals to st.text_input in the bracket, enter your query in plain English, key equals to input. This allows users to type their questions, such as show all students with marks above 80. A submit button triggers the SQL generation process, and for that we'll write submit equals to st.button in the bracket generate SQL query. When clicked, the app processes the query and retrieves the result. Now, we define what happens when the submit button is clicked. For that, we'll write if submit in the next line response equals to get_Gemini_response in the bracket question comma prompt. This is to convert the question to SQL. And then we'll print the response. Then we'll write response equals to read_SQL_query in the bracket response comma student.db, and this is to execute SQL on the database. Then we'll write st.subheader in the bracket the response is brackets closed. Next we'll include a loop for then row in response. Then we'll write st.subheader in the bracket the response is, and then we'll include a loop for row in response. Then we'll print row and then st.header and in the brackets row. The user's question is converted into an SQL query using Gemini AI. The SQL query is executed on the StudentDB database and the retrieve records are displayed on the Streamlit app. And that's it. The AI-powered Streamlit app allows users to ask natural language questions, which are automatically converted into SQL queries and executed on a student database. Now, let's open the terminal and run our Streamlit app. To do this, we simply type streamlit run app.py and hit enter. It's running, and as you can see, our Agentic AI is up and running, ready to interact with our database. Let's test it by asking a simple question. We'll ask, give me the names of all the students. The AI processes our request, converts it into an SQL query, and retrieves the student names from the database. Perfect. As you can see, the response is generated. Now, let's try another query. We'll say, give me the average of marks. And just like that, the AI calculates and returns the average marks. The response which is provided is 72.2. So in this video, we successfully built an Agentic AI that can understand natural language, generate SQL queries, and interact with our data seamlessly.
Now let's jump into a quick quiz question. And the question is, what is the core feature that differentiates Agentic AI from traditional generative AI? And the options are A. It generates better images. B. It responds faster to prompts. C. It can take autonomous actions toward goals. And D. It uses less data to train. And if you know the right answer, please drop it in the comment section below. Now that we have covered the concepts and differences, so let's look ahead. Where is Agentic AI going? Now it's time to check out the Agentic AI roadmap. AI is no longer just responding, it's acting, planning, and automating entire workflows. Welcome to the era of Agentic AI, where AI agents can write code, run businesses, and make decisions without human input. By 2030, AI automation is projected to be a $200 billion industry, and those who master Agentic AI tools like AutoGPT, Devin AI, and LangChain will lead the future. In this video, I will give you the ultimate roadmap to mastering Agentic AI from programming basics to real-world automation. So stick around and let's dive in. Now let's dive into the ultimate roadmap to mastering Agentic AI. So first, let's see how you can build a strong foundation in generative AI. To truly master Agentic AI, you need a strong foundation in generative AI, understanding how AI models work, their evolution, and their impact on automation. So start by exploring how AI has evolved from rule-based systems to advanced models like ChatGPT, AutoGPT, and Devin AI. You can check out Edureka's video on what is generative AI and generative AI examples for valuable insights into the fundamentals of generative AI, its real-world applications, and how it is transforming various industries. So first, understand the core concepts of Agentic AI, where AI can perceive, plan, and act independently to automate complex workflows. Next, learn about real-world applications such as business automation, AI-powered software engineering, and autonomous research agents. And to deepen your knowledge, familiarize yourself with the key AI models like GPT-4 Turbo, Claude AI, Gemini, and Mistral, and stay updated on multi-agent systems and self-improving AI trends. And for hands-on exploration, leverage OpenAI's API, Claude AI, and Llama 3, or experiment with different AI models on Hugging Face spaces. You can also stay updated with AI research papers from 𝐸𝐵𝐼 and Hugging Face to keep up with the latest breakthroughs. Edureka's generative AI certification and training will teach you Python programming, data science, artificial intelligence, natural language processing, and so many other updated technologies that a beginner or advanced learners is seeking. And by understanding these concepts and experimenting with these tools, you will have a strong foundation to start working with Agentic AI. Next, let's dive into the programming for AI. To build and experiment with Agentic AI, you need to understand the fundamentals of programming, especially in Python, which is backbone of AI development. Start by learning Python basics, focusing on data structures, loops, functions, and object-oriented programming. Then, explore essential AI and machine learning libraries like NumPy and Pandas for data manipulation, Matplotlib and Seaborn for data visualization, and TensorFlow and PyTorch for deep learning. To work with AI agents, you must also understand API interactions, as most AI tools like OpenAI's API, LangChain, and Hugging Face models require API calls. Additionally, learning automation with Fast API, Flask, and web scraping can help you integrate AI into real-world applications. For hands-on practice, start small projects like building a chatbot, creating an AI-powered summarizer, or automating data analysis. You can also explore Edureka's Python training and certification course designed by industry experts, where you will learn Python from scratch along with key libraries like NumPy, Pandas, Matplotlib, and scikit-learn through hands-on project and real-world applications. With this powerful prompting techniques and tools, you will be able to optimize AI responses and unlock the full potential of Agentic AI. To leverage Agentic AI, start experimenting with cutting-edge tools that enable autonomous workflows. AutoGPT and 𝐶𝐻 allows you to create multi-agent AI systems, where AI agents collaborate to complete tasks. Baby AGI is perfect for automated research and decision-making, helping AI iterate on tasks dynamically. Devin AI, the first AI software engineer, showcases how AI can independently write, debug, and deploy code. For hands-on learning, build real-world projects like AI-powered automation, assistants, autonomous research tools, or self-improving chatbots to see Agentic AI in action. By working with these tools, you will understand how AI can move beyond just responding to acting intelligently and autonomously. Next, explore LangChain and RAG, powerful tools that give AI the ability to retrieve real-time information, process external data, and enhance decision-making. To build more powerful and context-aware AI applications, understanding LangChain and RAG is essential. LangChain is a must-learn framework that enables seamless integration of LLMs with external data sources, allowing AI agents to interact with APIs, databases, and documents. RAG enhances AI models by providing memory and real-time knowledge retrieval, making responses more accurate and up-to-date. For hands-on learning, try building your own AI chatbot with LangChain, capable of retrieving real-time information instead of relying on static training data. A great project idea to explore is an AI-powered research assistant capable of summarizing papers, fetching real-world data, and answering domain-specific questions. And to dive deeper, check out our dedicated video on LangChain and RAG where we cover everything in detail. Next, here are the extra tips for your success. To excel in Agentic AI, consistent practice and community engagement are key. So start by pushing your AI projects to GitHub and using version control like Git to track your progress and collaborate. Join AI communities on Discord, Twitter, and Hugging Face spaces, where you can interact with experts and stay updated on trends and get feedback on your work. Take advantages of AI internships and open source projects to gain real-world experience and build a strong portfolio. Also stay updated by regularly reading AI research papers on 𝐸𝐵𝐼 and Google Scholar, keeping up with the latest advancements in multi-agent AI and automation. And by following these extra tips, you will accelerate your AI learning with career growth. And with this, we have come to an end to this session on Agentic AI. If you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. Thank you for watching and happy learning.